This is Math Counts 2017, workout number 3, and we are looking at 98 through 200. And for those of you who watched the previous video, I hit the wrong button. Oops. So I'll start over. So in 1 year, we get $700 million worth of paper money every day. That is a lot of money per day. For 365 days. Half the total value came in $1 bills, which is $100 bills. If a new dollar bill is 1 gram, what was the weight in kilograms of all the $1 bills printed? Well, if half of the value is $1 bills, so that's 350 million $1 bills per day. That's a lot of bills per day. And each bill weighs 1 gram, so it stands to reason that we have 350 million grams of dollar bills per day. Well, there are 1,000 grams in a kilogram. So that means we have 350 kilograms of dollar bills per day. But wait, that's in 1 day. We want per year. So we have 350,000. That's so much. There we go. Times 365 days. And we get this monstrosity of a number for how many kilograms of dollar bills the US government printed in 1 year. Oh my goodness. And that is the correct answer. For those of you who want me to read it out, that's 127,750,000 kilograms. That is a lot of paper money. All right. Number 99. Now we've done this one in class, but I'll do it again. So the first thing that I would suggest doing in this case is shrinking this so I can. So is to realize that this function can be factored. So we have 225 n minus n to the third, and we're trying to maximize the number of bushels we can get in an acre. And here's the thing: you can plant more trees in an acre than the optimum amount, but then that's forcing the trees to fight each other for nutrients, and therefore your apples will not be as big. They won't be as good, and each tree will not produce as many. So there is an optimum number here, not just as many as you can plant. And I realize that I can factor this because both share a term of n. So I have n times 2,225 minus n squared. Well, this is a difference of squares. This is a perfect square, this is a perfect square, and I'm subtracting them, difference of squares. So I have n times 45, which is the square root of this, plus n times 45 minus n, which means my zeros, what I mean by zeros is this graph would look an awful lot like this. I'm trying to find this number right here. My zeros are going to be 0, and there's my 0. This would be negative 45, and this one here would be positive 45. So we are looking for a number in between 0 and 45, and I also know, because I've seen these enough, that there's not necessarily going to be a line of symmetry for what looks like this parabola, but it's not a parabola, it's a cubic function. So it is fair to say that we should start looking when n is equal to 22. And we're going to continually plug in these numbers until I get a number that is, until the number of bushels starts to decrease. So here we go. Oh, I want that. So let's go 22. So I put 22 into both of them. So 45 plus 22. And I'm going to multiply that by 45 minus 22, which is 23. I'm going to multiply that by my 22 again, and I get 33902. Now I'll do this again just to show you, but then I'm going to jump to the full complete table just to make life go faster. So then we have 45 plus 23, which is 68, times 45 away b 45 minus 23, which would be 22, times my 23, and I get slightly more. Slight being a relative term, obviously. And then I will continue the table until I see that it's starting to go down again. So then we have 34,400,776. It's all getting bigger. Then we have exactly 35,000 bushels. And notice how the difference is getting smaller each time. At 26, we only include 74 more bushels, but 74 more bushels is better than not more bushels. And then at 27 trees per acre, we go back to 34,992. And so clearly, 26 trees per acre is going to be my optimum. All right, finally, the last one. And I will admit to stumbling on this one during class. It's always harder in class when there are students around for me to follow what the instructions say. So if that was you, don't worry about it. There were so 3 days ago, there were pea cupcakes. Friday is the best day, right? So today is Friday. Tomorrow is going to be Saturday, then Sunday, then Monday, then Tuesday. So 3 days ago, there were pea cupcakes on the counter. 2 days ago, there's exactly 20% of them. So let's say we have 100%. So this is pea cupcakes. So 2 days ago, that's 1 day before, or 1 day after rather, we have 4/5 remaining pea. Today, there were 30 fewer cupcakes than yesterday. So here, there are 30 fewer than this day right here. How am I going to express that? Well, here is what I'm going to do. Fewer, and half as many as there were 3 days ago. So in 3 days, we have 1/2 pea. And so then here, we need to figure this out, right? So we have 30 fewer cupcakes yesterday. So that means we have 30% more. How am I going to express this? All right, so here's how we're going to express this. We know that 30 fewer cupcakes means that 70% of the cupcakes remained, right? So in other words, to go from here to here, we're going to multiply in terms of what's remaining. 7 out of 10, right? But we don't have the number here to go here. We're trying to go backwards, right? So we're going to do that, and this is just like a scale factor problem. We have to multiply by the reciprocal because we're going the opposite way. So we have 10/7 times my 1/2 p. So now here's the thing. We are looking for a number, p, that can be evenly divided by 5, by 7, and by 2. What number is divisible by all of those things? Well, they don't share any, they're all relatively prime, which means they don't share any common factors, which means that all we have to do is multiply these together, and we get 70. Now, the interesting thing is, this is how Zach and Tate did it. If you don't know Zach and Tate, great kids. But this is how I did it. So what I did is I went ahead and I made a, so I took what it said. It said exactly 20%. And so when it says 20%, that means that 4/5 remain. And then it goes on 30%, which means what remains? 7 out of 10 is remaining. So I know this times the number of cupcakes is going to give me a ratio, but I don't know what that ratio is, right? So in relation to the original. So I know that there's going to be some scale factor that I'm going to have to multiply that by. And so that's going to give me 28/50 times my scale factor times the number of cupcakes I have. Then it goes on to say that 3 days later, I'm at 1/2. So this is going to be equal to 1/2 times my p. So all I have to do is solve, and I should get my x, my scale factor, so to speak. So let's divide both sides by p. If I divide everything by p, the p's cancel out. And so I get 28/50 x is equal 1/2, multiply by the reciprocal, which is 50/28. These cancel out here. So I get x is equal to 25/28, right? So that is the scale factor by which I am working with. Now, I know that I'm looking for a value of p that is both divisible by 5 and also divisible by 28. So what is 5 times 28? It's 140. But 140 is not quite the answer, is it? Because 140 is twice of 70. So 140 would work. So are there any other numbers that would also work, right? So at this point we know that if we divide by 2 we get 70, and so there is my answer.